have to run through it. So at that point where you now look at the number of atoms of a particular element on the left, how many they are, and how many they are on the right, that is where now we come up with the issue of balancing. However, the other guiding principle that we can get from here is that calcium hydroxide is a base. And then hydrochloric acid, we know very well, it's an acid. Therefore, each time an acid and a base react, what forms is a salt without any compromise, water has to be formed. Unless this base that we have here is a metal carbonate. If it's a metal carbonate or a metal hydrogen carbonate, because of the carbonate CO3, that is how not only water is formed alongside the salt, but because look here, H2O, there's one oxygen atom present. So when you remove one atom of oxygen from the carbonate here, you'll find that CO2 is also going to be formed alongside. Maybe let me write it up as a second example. So the second example, we're going to have calcium, which is a metal carbonate, calcium carbonate. This is calcium carbonate, which is a base, of course, plus an acid, which is this time around, let's have a no, maybe a different one. Let's have hydrochloric acid. Hydrochloric acid. So here, when you look at this in a similar manner, we said here there is calcium and there is a carbonate. There are two. There is a hydrogen and there is a chloride here. There's chlorine as an entity. In a similar manner, we are going to have a double decomposition or a double switching of ions, where the metallic component that we have in the first reactant, which is calcium, calcium is coming to sit where hydrogen is so that it is bonded to chlorine. That is how we're going to have calcium chloride. But remember, due to differences in terms of valences, calcium has a valence of 2, chlorine has a valence of 1. That is how a 2 is coming here. But we should not look at how come there's only 1 chlorine here and here we are forming 2. What has caused us to have that 2? It's because of differences in terms of the valences, that of calcium and that of chlorine. Plus, so what we have here is a hydrogen, which is a metallic component in our second reactant. Now here, we are also going to pick. We are not going to have hydrogen here and the carbonate. It means we are going to have, again, an acid, which is carbonic acid. So when you react an acid and a base, you cannot form a salt and acid. No, because this calcium chloride, which is a salt, we are likely to have a pH around 7 because it's neutral. And when we form an acid whose pH is less than 7, therefore the pH of the resulting solution will not be balanced. So that is why we are saying we are going to pick one oxygen from here, and now when hydrogen and oxygen combine in that way, what is coming up is water, so that even the second product, the pH should be around that of a salt. It must be neutral. That's how the water is coming about. Plus, because we only got one oxygen from here, and there is already carbon with 3 oxygen atoms, removing 2 gives us a position where only 2 oxygen atoms are remaining. And what do we know about carbon dioxide? Carbon dioxide is, though it's considered to be an acidic gas, however, in such a situation, you will find that it is produced as a byproduct, and this gas is it evolves, it comes out of the solution. And therefore, the only thing that will remain in that solution is calcium chloride as well as water. This gas will be given out because under specific conditions, when this gas is allowed to react with water, an acid is resulted. But in this way, the gas which is produced escapes. So that is how you can tell the products that are coming to be formed. We okay? Let me put up the third one. The third one, I want you to complete it. The third one is going to be the third one is calcium hydroxide. Calcium hydroxide. Calcium hydroxide is reacting with carbon dioxide. Calcium hydroxide is reacting with the carbon dioxide. What do you think is likely to be formed? What are we likely to form? What are we likely to form? What are we likely to form? Yes. What are you likely to form? Yes, Pezo?
Is it calcium carbonate and water?
Calcium carbonate. Which calcium carbonate, which is a solid, plus water. What is that all about? Don't worry, this is your submission. This is your submission. Trisha, what do you think we like it from here?
Okay, to be honest, I found the same thing.
Oh, to be honest, you found something? I see.
Yeah, but I was thinking calcium oxide because of the O, but it didn't make sense.
Remember, an oxide is formed when a metal reacts with oxygen, not with a carbonate. So the calcium oxides, I don't agree with it. So this, first of all, do you know where this reaction is used? Do you know where the reaction is used?
No.
In grade 7, grade 9, they told us that this, remember this calcium hydroxide, which is in aqueous, this is lime. This is lime water. This is lime water, and reacting with the carbon dioxide. Carbon dioxide, what did they say? That when you bubble carbon dioxide through lime water, the lime water is turned milky. So the milky substance that is formed is calcium carbonate. Now that milk substance is gonna be inside of a solution, inside of a liquid, and that liquid is water. So when you're testing for carbon dioxide, the identity test for carbon dioxide, actually what goes on within the chemical reaction is exactly what you guys have said. This is correct. So during the testing, during qualitative analysis for gases, they tell us that when you want to test whether the gas you are given is carbon dioxide, let this gas be bubbled through lime water, which is calcium hydroxide in aqueous solution, and then a white PPT. It's formed, the milky solution that we see, the white part, the milky part is because of the presence of calcium carbonate, which sits inside of water. So that is correct. That is very good. The fourth one is a decomposition. It's a decomposition of this chemical species, which I want you to identify. The decomposition of this compound when this solid decomposes, what are you likely to form? What are you likely to form? Though the decomposition of this substance is a little bit reversible. Is a little bit reversible. What are you likely to form? What are you likely to form? What are you likely to form? Yes. What are you likely to form? Guys, you heard me. What are we likely to form? Okay, maybe let me help you out. From here, what are the two chemical species that we have? We actually have the ammonium, it's not ammonia, but ammonium, as well as chlorine. So ions, we have ammonium. We also have chloride ions. One thing that you should know is that I'll give you 4 chemical species. NH4, which is ammonium, this one is positively charged. This chemical species, which is NH3, which is ammonia, is neutral. The chloride ions, negatively charged. Then the hydrochloric acid or hydrogen chloride, these two make up a neutral chemical species. So at least I've given you a hint. Remember, when the chemical reaction is taking place, what we are seeing in a balanced chemical equation are chemical species and not ions. So I've given you a clue. What is it that is likely to be formed? Yes?
I think ammonia and hydrochloric acid. I'm
Ammonia,
not sure.
ammonia. So let's have NH3. And we understand very well that NH3 is a gas. Now, when you say hydrochloric acid, we're supposed to have aqueous. What does it mean, aqueous? Meaning this thing is sitting inside of water. Or rather, we can say that this acid is diluted. But on the contrary, this is happening. Remember, during decomposition, heat is involved. So that water does not come anywhere near the products. As a result, what we are going to have here is a gas. And this gaseous form of HCl is not hydrochloric acid, but it is a hydrogen chloride. So that is a hydrogen chloride, but not hydrochloric acid. Okay. What about the decomposition of calcium carbonate? Calcium carbonate decomposes. What are we likely to form? 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 What are we likely to form?
Calcium oxide and carbon dioxide. Right.
Calcium oxide and carbon dioxide. Okay. Trisha?
I don't know. I'm not sure on this one.
I see. So this calcium, when separated, this calcium, when separated from a compound, if we were to separate these two, calcium will be positively charged. The carbonate, CO3 will possess a negative charge. Calcium, or then the oxide, just oxides, as an oxide, it's going to have 2 minus 2, or O minus 2, and then calcium, when this substance and this substance combined will form calcium oxide without a charge. So when this carbonate is allowed to be reduced to a carbon dioxide, this carbon dioxide is neutral. So what is formed from this chemical reaction that we have are these two. These two are the ones that are formed from the decomposition of calcium carbonate. What is formed is calcium oxide as well as carbon dioxide. And that is why this is one of the ways in which we form calcium oxide, which is called quicklime. We did this question in class. Yes. So where are you still having issues on how to complete the reaction? Yes? Where are you still having issues? Let me give you one. Ammonium chloride. Ammonium chloride plus plus nitric acid. What are you likely to form? Ammonium chloride as well as nitric acid. What are we likely to form? Yes, Richard.
I think we are going to form ammonium nitrate and hydrochloric acid or hydrogen chloride. I'm not sure. The two.
You should be sure and I will.
Okay, hydrochloric acid.
So she says ammonium chloride. as well as plus
No, it said ammonium nitrate.
or ammonium nitrate rather. Okay. Ammonium nitrate plus plus hydrogen chloride. Okay. So what do you think? So what do you think we're going to?
I think it's ammonium nitrate. Ammonium nitrate and HCl also. I'm not sure, but that's what I think.
When you say you're not sure, it means you are likely to change the answer that you produce in the first place. So think through it, be convinced of a certain answer, then give it out. Now, when you say, I'm not sure, I think, it means even in an exam, you're likely to change it. Yes, so you are right. It's a double decomposition where this and that separate. This comes and take the place of that, and this comes and take the place of that to form ammonium nitrate as well as hydrogen chloride. Why is it important to